Hello friends, in today's session we are going to analyze and solve some very interesting questions from the 2018 JEE paper, especially the maths part. And let's quickly do an overall analysis of paper 1 and paper 2. Paper 1, there were actually 6 multiple correct answer kind of questions from these different chapters. There were 8 numerical kind of questions from these different chapters. And then we had some passage kind of questions which were from these different chapters. Now here is the percentage of questions which came from different chapters. Now, speaking about difficulty, if you were to ask me, some questions were easy, most of them were medium difficulty or hard questions. And these questions can be solved only if you are well aware of the concepts and have done a lot of practice throughout the 2 years. The division of questions from 11th and 12th standard more or less the same, with the balance slightly in the favor of 12th standard in paper 1. Paper 2 had an almost similar kind of premise. In fact, if you see, the division does not change a lot in your paper 2. Paper 2 was more or less similar, except for the fact that the third section was different in paper 2. Instead of the passage kind, we had matched the following. More or less similar paper, and if you actually compare paper 1 and paper 2, you will see that whichever section was not tested in paper 1 was tested in paper 2. Now, we're going to start by looking at complex numbers. We had a multiple correct answer kind of question coming from this section that is on complex numbers. Now remember, in the 2018 paper, partial marks were awarded for each correct option in the multiple correct answer kind of questions. So this means that even if you get one of the correct answers in this question, you are sure to get some marks. So never leave any multiple correct answer questions. Attempt at least to get one correct answer. Now this question, of course, it's more exciting because they've asked us to check which of the given options are false. Even if you find 1 or 2 options which are false, you are sure to get some marks. So let's start this question. Now when you do questions of these kinds, it's not important that you do them in order. Whichever option seems like the easiest one to start with, you start there. Now in this question, the easiest option is option A, because in option A, they've asked us to check the argument of the complex number -1 minus iota or I. So the statement says that the argument of the complex number -1 minus I is equal to pi by 4, and I already know that this is false, because -1 minus iota lies in the third quadrant, and in the third quadrant argument cannot be pi by 4, because pi by 4 is an argument for a complex number in the first quadrant, so it is false. Technical details: what is the argument of -1 minus iota? It's nothing but minus of pi minus pi by 4, which is nothing but minus 3 pi by 4. So already I've got one answer correct, so which means I've already got some partial marks for this question. Next, I'm going to look at the third option. So what is the third option? In the third option, they've asked us to check if the argument of z1 by z2 minus the argument of z1 plus the argument of z2 is some integral multiple of 2 pi. To be very honest, I don't like this question. The reason why I don't like this question is because the principal argument always lies between negative pi and positive pi, and here they've told us that the argument of this entire expression is an integral multiple of 2 pi. So remember that any angle when added with 2 pi still remains the same in our entire quadrant system. So that's how we're going to approach this question. So let's simplify. This is a very simple, straightforward question. Argument of z1 by z2 is nothing but argument of z1 minus argument of z2. And then you have minus of argument of z1 plus argument of z2. The entire thing cancels out and you get the total argument to be equal to 0. Now we know that 0 degree angle is exactly the same as 2 pi angle or 4 pi angle or negative 2 pi or negative 24 pi. It doesn't matter which integral multiple of 2 pi we consider. All of those angles are exactly same in our quadrant system. So in fact, this entire expression is an integral multiple of 2 pi, which means this option is true and we don't mark this option. We will now look at the second option. The second option seems to be a little more simpler than the fourth option. So we look at the second option. So what has been told in the second option? In the second option, we have been given a function which is from real numbers to negative pi to pi. And this function is defined as the argument of negative 1 plus iota t, a complex number negative 1 plus iota t, where t can be any real number. And the objective is to check if this function is continuous for all real numbers t. Now, what's the complex number? The complex number is negative 1 plus iota t, which means that the real part of the complex number is always negative. So this complex number is going to lie in the second quadrant or the third quadrant, depending on the sign of t. Now, what happens if t is 0? If t is 0, this complex number is minus 1. So the argument is going to be pi. What happens if t is slightly positive? If t is slightly positive, the argument is going to be pi minus whatever that angle is in the second quadrant. What happens if t is slightly negative? If t is slightly negative, the argument is going to be negative of pi minus that angle. So if you plot the arguments, you will clearly see that the limit of the function does not even exist when the value of t is equal to 0, because as t becomes positive, the argument is going to be a positive number, which is going to be a very big number, very close to positive pi. And as t becomes negative, the argument becomes negative, a very large negative number, which is very close to negative pi. So there is a big jump when t is equal to 0, which means this function is not continuous, as the limit itself does not exist at t is equal to 0. So this statement is false. We've got 2 out of the 3 answers correct already, in case there are 3 correct answers, because we still have to check the fourth option. So we've got 2 answers correct. Maximum of 3 answers can be correct for this question. So let's check the last option and see for ourselves if that is also false. So option 4, a little bit twisted and tricky. We've got 2 answers correct already. So in case you feel that there is a time crunch, do not do this question. In case you feel there is enough time, you can actually do this question and check for yourself if it is false, because if it is not false, then there were only 2 correct answers to this question and you've already got both of them correct. So in case you have time for this question, definitely attempt this question. Those who find coordinate geometry and complex numbers association a little difficult, I would advise you not to touch this question. But this is how you would go about the question. In the question, what has been asked is the locus of a complex number z which satisfies this particular statement, that is the argument of z minus z1 into z2 minus z3 divided by z minus z3 into z2 minus z1 is actually equal to pi. And so this complex number z lies on a straight line. Actually a very simple question if you visualize this question and do it in the right way. So what do? We are going to divide this argument into 2 different arguments. We're going to consider argument of z minus z1 divided by z minus z3 in one section, and then plus the argument of z2 minus z3 divided by z2 minus z1 in another part. So the sum of these 2 arguments is equal to pi. We can do this using property of argument, and then I'm going to visualize. So how do we visualize this? Well, we have 4 complex numbers, so let's mark these 4 complex numbers z, z1, z2, z3. Now let's try and represent our statement. Argument of z minus z1 divided by z minus z3. Now what's that? This complex number and this complex number, the angle formed between them. So z minus z1, z minus z3, the angle between them is going to be the argument. And then you have z2 minus z1 and z2 minus z3, which means z2 minus z1, z2 minus z3. The argument of that is going to be the angle formed between them. Now these 4 complex numbers form a quadrilateral, and according to our statement, these 2 angles add up to give pi. Now when will this happen? When will a situation arise wherein there are 4 points which form a quadrilateral and the sum of the opposite angles is 180 degrees? It has to be a cyclic quadrilateral, which means that that quadrilateral has to be inscribed inside a circle, which means point z, the complex number z, actually lies on a circle and not a straight line. So this option is also false. So this was the 3rd correct answer to this question. So this question in fact has 3 correct answers, and now we've marked all of those answers. So that was a question from complex numbers, and it was a multiple correct answer kind of question. Slightly lengthy, but it still was not one of the difficult questions which appeared in the exam. It was a relatively simple to at most a question of medium difficulty. So in the paper, we had 3 different kinds of questions in 2018. In the first paper as well as in the second paper, we had 6 multiple correct answer questions, which would fetch you a maximum of 4 marks if you got all the answers correct, or partial marks for some correct answers, and a -2 if you marked even one wrong answer. Then there were numerical kind of questions for which you had to input a numeric as the right answer. A numeric up to 2 correct decimal points was what was instructed in the question paper. Now there were 8 different kinds of numerical questions in both paper 1 and paper 2, and these questions carried 3 marks for each correct answers and no negative marks for wrong answers. Let's quickly try and solve one numerical kind of question from the chapter on limits, continuity and differentiability. Well, this is a limits question with a little bit of integration in it. It's actually still a question of medium difficulty and not a very difficult question. So let's quickly see how to solve this question. In this question, they've given us that n is a positive integer and yn, this is 1 upon n multiplied by n plus 1 into n plus 2 into n plus 3 all the way until n plus n, all to the power 1 divided by n. Now, limit as n tends to infinity of yn is said to be equal to L. The objective is to find the greatest integer of L. So how do you go about this question? The first few steps, pretty straightforward. What you do is you take the 1 by n inside. So in order to take this 1 by n inside, you raise 1 by n to the power n, and then the whole thing is raised to the power 1 by n. So you actually effectively end with just 1 by n. So 1 by n to the power n goes inside the bracket, which means you have n different 1 by n's getting multiplied to each other. And so you can divide each of the n terms by n and rewrite yn in this way. Yn is now nothing but 1 plus 1 by n into 1 plus 2 by n all the way till 1 plus n by n, and then the whole thing is raised to 1 by n. Now we need to take the limit of this as n tends to infinity because that's what is L, and we need to find L and then find the greatest integer of L. Now this is a function which is something like f of x to the power g of x. So if f of x to the power g of x, when we take limits, we always make use of log, and log and limit can be interchanged. So the left hand side I'm going to write it as the log of limit as n tends to infinity of yn, right? But in the right hand side I am going to interchange the log and the limit. I'm going to write it as limit n tending to infinity of 1 by n and then the log of everything. See, I've used the property of log, which is log a to the power b is nothing but b log a. And also the term which is basically the argument of the log is a product of terms. So I can then write it as log of 1 plus 1 by n plus the log of 1 plus 2 by n plus the log of 1 plus 3 by n and so on, which can be rewritten in a very short way as a summation series, which is nothing but sum of r going from 1 to n of the log of 1 plus r by n. Now this is where you should know what a Riemann sum is. Now this expression can be converted into a Riemann sum, and the log of L now becomes integral from 0 to 1 of log of 1 plus x dx. This is the concept of Riemann sum, without which you cannot proceed in this particular question. So in the chapter on limits, you should always focus on Riemann sum and have a little understanding of Riemann sum to be able to solve advanced level questions. This is a very straightforward integration. I just changed the variables initially. Integral from 1 to 2 log of t dt. Solve the entire integral and then you end up with log of 4 by e. Now 4 by e is a number which is slightly more than 1, right? E is 2.71, 4 divided by 2.71 is 1 point something. So L, which is 4 divided by e, when you take the greatest integer of it, you end up with 1. So 1 is the correct answer to this numerical question. Not a very simple question, but if you knew the Riemann sum concept, then you could actually solve this question and get full marks for this particular numerical kind of question. A very interesting question from limits, continuity and differentiability. So we've seen 2 questions, one from complex numbers, one from limits, continuity and differentiability, which comes from the section on calculus. Well, it was no coincidence that I chose these two questions because these two questions represent two sections which are of the most importance in your advanced examination: algebra and calculus. Now, from calculus, there were 4 out of 18 questions in paper 1 and 5 out of 18 questions in paper 2. Now, this is a big chunk. Almost 25% of the paper is from just one section, which is calculus. When I talk about algebra, well, there are a lot of chapters here, chapters such as binomial theorem, sequences and series, complex number, matrices and determinants, trigonometry. These are all, clubbed under one umbrella called as algebra. And this big section fetches a lot of questions. There were approximately 8 and 9 questions in the advanced examination paper 1 and paper 2 of 2018 if you club all these chapters under one umbrella called as algebra. So algebra and calculus, these both are very, very important sections. And so I'm going to solve one more question from the big umbrella of algebra, this time from trigonometry. In this question, they've told us that alpha and beta are two distinct real roots of the trigonometric equation root 3a cos x plus 2b sin x is equal to c, wherein x lies in the interval negative pi by 2 to pi by 2, such that alpha plus beta equal to pi by 3. Now the objective is to find b by a, and this is a numerical kind of question. So let's say that the tan of x by 2 is equal to t. Now, this is the trick to solve this question. If you do not understand that this question has to be solved using tan half angles, I am sorry, you will not be able to proceed. So this is what makes this question a slightly difficult question, because as soon as you see the question, you should understand the approach, and this will come with a lot of practice alone. So you have got to convert causes and sines in this question into tan half angles and rewrite your equation in this particular way, and then do a little bit of manipulation. You take the common denominator of 1 plus t square and then bring in all the like terms together and write a quadratic in terms of t, and you get this particular equation here. So the trick does not end here. This is not the end of the trick. There is a little more to the trick. We know what t is, because what is t? T is nothing but tan of x by 2. And x can take values alpha and beta, because alpha and beta are two distinct real roots of the equation in x. So x can take values alpha and beta. So t can take values tan of alpha by 2 and tan of beta by 2. So tan of alpha by 2 and tan of beta by 2 are the two roots of this particular equation. And what is the sum of the roots? The sum of the roots is nothing but minus b by a, and from the quadratic I am going to get tan of alpha by 2 plus tan of beta by 2 to be equal to this term here. Now since I found out the sum, I'm also going to find out the product of the roots. Tan alpha by 2 into tan beta by 2 is c by a, which is going to give me this term from the quadratic equation. It does not end here, friends. There is more trick to this question, because now you're going to use the formula tan alpha plus beta, because alpha plus beta is pi by 3. So tan of alpha plus beta will be tan of pi by 3. But we don't have anything in terms of alpha plus beta. We have everything in terms of alpha by 2 and beta by 2. So we are going to say alpha by 2 plus beta by 2 is pi by 6, and tan of alpha by 2 plus beta by 2 is tan pi by 6, which is nothing but 1 by root 3. Now tan of alpha by 2 plus beta by 2 is nothing but tan alpha by 2 plus tan beta by 2 divided by 1 minus tan alpha by 2 into tan beta by 2. Now, do we have the expressions for tan alpha by 2 plus tan beta by 2? Yes, indeed, we have. And so, do we have the expression for tan alpha by 2 into tan beta by 2? So, I'm going to substitute all these here, and you will clearly see that the C's are going to get cancelled out, and I'm going to be left with b and a, and that is what was the object of the question. We have to find what is b by a. And now, so I have 4b divided by 2 root 3a equal to 1 root 3. I'm going to cancel out the root 3's from the question, and I will be left with 4b by 2a equal to 1 once I cancel out the root 3's. So this means that my b by a is going to be 1 by 2 which is nothing but 0.5. So B by A is 0.5. It's a numerical kind of question which we have to answer to exactly 2 decimal points at max. So 0.5 is the correct answer to this question. It was not a simple question because it involved multiple concepts and it required you to use a trick which you will never know unless you have solved a lot of questions of this kind. So this is actually a slightly tricky and hard question from the paper, and this came from the section of algebra. In addition to algebra and calculus, another section which fetches a lot of questions is coordinate geometry. Now, coordinate geometry includes the conic sections such as the parabolas, the ellipses, the hyperbolas, circles, 3D and vectors. This entire section, which is coordinate geometry, will normally fetch 4 or 5 questions, and in 2018 paper 1 and 2, there were 4 and 5 questions respectively from this section on coordinate geometry, another very important section. And generally, if you remember things from this section, solving questions from here is easy. Parabola is one single most important chapter from the entire syllabus because a question from parabola is a sure shot in your advanced examination, and that was the scene in 2018 as well. I'm going to solve a question which involves parabolas, circles and ellipses. This was a question which appeared in the 2018 paper, and this was actually a multiple correct answer kind of question, a very interesting multiple correct answer kind of question. I say this because the objective of the question was to find out which of the statements given were true. Now look at the options. The first 2 options contradict each other. The next 2 options contradict each other. So in the first 2 options, you have to find out the eccentricity and the length of the latus rectum. In the third and the fourth options, you have to find one particular area. So if option A is correct, B is wrong. If C is correct, D is wrong, and vice versa. Which means that you have to actually effectively solve only 2 questions in this multiple correct answer kind of question. So a very exciting question from Ellipse. And this was an easy to moderate difficulty light of question, not a very difficult question. So what has been told in the question, we have a circle, x square plus y square is equal to a half. So it's a circle of radius 1 by root 2. And then we have the standard parabola, y square is equal to 4x. There are 2 lines which are both tangents to the circle and the parabola. So the lines are tangents to the circle and the parabola, and they meet at a point, let's say Q. What is interesting is there is an ellipse with its center at the origin 0, 0. Now this ellipse has the point Q as one of the endpoints of its major axis. The length of the minor axis of this ellipse is root 2 units, and now we've been asked to find out the eccentricity of the ellipse and the length of the latus rectum of this ellipse. A very, very straightforward question in my opinion if you know formulae. Now, what is the equation of a tangent to a parabola? It's nothing but y is equal to mx plus 1 by m. But we know that this line y is equal to mx plus 1 by m is also a tangent to the circle. Now what's the property of a tangent to a circle? A tangent to a circle is actually perpendicular to the radius. So the distance of the center of the circle from the tangent is nothing but the radius. And so we are going to use that formula of distance of a point from a line, and using that arrive at what is the value of m. M turns out to be plus or minus 1. So the 2 tangents are very simply y is equal to x plus 1 and y is equal to negative x minus 1. Point of intersection of these 2 straight lines, very, very simple. Q is equal to negative 1, 0. So I found out what is the coordinate of point Q. Once I find out what the coordinate of point Q is, it's very straightforward to solve the first question, because now we have the equation of the ellipse. What's the equation of the ellipse? The equation of the ellipse is x squared by 1 plus y squared divided by 1 by root 2 the whole square, because the length of the minor axis was 1 over root 2. So y squared divided by 1 over root 2 the whole square equal to 1. Find out the eccentricity. You know the A, you know the B, you know the formula for the eccentricity. The eccentricity turns out to be 1 by root 2. Formula for latus rectum, 2b squared divided by A. Plug in the values of B, plug in the value of A, and you have the value for the length of the latus rectum. So you found out what the eccentricity is, you found out what the latus rectum is. Figure out which is the correct option. Option A is true, option B is false. So you already have got one option correct. Very easy question, very quickly you could do it, and you actually have got partial marks because multiple correct answer questions have partial marks. Now, even if you don't want to solve the area question, you have some marks in your kitty. That's the advantage with partial marks in multiple correct answer kind of questions. But if you are someone who wants to score a lot of marks in this section, because this section is easy, you will go on and attempt the second part of the question, which speaks about the area bounded by the ellipse, the line x is equal to 1 by root 2, and the line x is equal to 1. Now, how hard is this question? Look at the area that you have to find out. A very simple area that you have to find out. It's a very simple integration question. The area is in fact symmetric about the x-axis. So you just have to find 1/2 of the area and multiply it by 2, and you arrive at the solution. The first thing that you need to do is rewrite the equation of the ellipse in the form y is equal to 1 over root 2 root of 1 minus x square, and then integrate this y between the limits of 1 by root 2 and 1 to get the upper area, and then you multiply it by 2 to get the lower area as well. So the total area is 2 times the integral from 1 over root 2 to 1 of the expression y, which was 1 by root 2 root of 1 minus x square dx. A very simple integration. Again, there's a standard formula for root of a square minus x square. You should remember that in your advanced examination. Solve a lot of different integration questions of this kind so that this formula gets into your head and it gets cemented, and then use that formula. It's a lengthy formula. Use that formula and you arrive at the answer very, very soon. The area turns out to be nothing but pi minus 2 divided by 4 root 2. Option C says this, option D says something else. So option C is the correct answer. So option A and option C were both correct, and we could arrive at the solution very easily, and be sure that option B and D are actually false. A very interesting and a very nice question which you should never skip in your advanced examination. So a very beautiful question from the chapter on coordinate geometry. In fact, the questions from coordinate geometry are of this kind. You should remember a lot of things, and to remember these things you have to solve more and more kinds of problems, derive these formulae yourself, and make sure that you're well acquainted with all these formulae, and then solving coordinate geometry questions will be easy. And coordinate geometry in fact fetches a lot of questions in the advanced examination. So in addition to algebra, calculus and coordinate geometry, there is yet another section which fetches questions in the advanced examination. And this section, which is generally an Achilles heel to a lot of students, is probability and permutations and combination. The reason why people are actually a little averse to this section is because even after practicing n different kind of questions, an n+1 kind of question appears in the examination and leaves you completely stumped. But in 2018, one of the questions from probability was not a question which would have stumped you had you solved a question of that kind. This question was a formula-based question, quite a rare scene in probability, but it did appear in a passage type of question. Yes, indeed, passage type was the third different type of question in paper 1. We had the multiple correct answers, we had the numerical, and then we had the passage type of question. One passage carried 2 questions, both of them single correct answer questions carrying +3 marks each time you got them right. In paper 2, passage type of questions were replaced by match the following kind of questions, which was almost a similar pattern, and it was also a single correct answer kind of question in paper 2. So both the papers had 3 different sections. The first 2 sections were common. The third section was match the following in paper 2 and passage type in paper 1. Probability actually got a question in passage type of questions, and this question was actually formula based, and let's quickly see what this question was. So we were given a passage, and then we were asked a few questions. So the passage says that we have 5 students in a music class S1 to S5, and they were allotted 5 seats R1 to R5. But in the examination, they were allotted random position. The first question asks us to find the probability that student S1 goes to his allotted seat, but the others don't. Now this question, if you've seen D arrangement, was a straightforward, simple question to solve. If you've not seen D arrangement, there is no way you could have solved this easily. So make sure that you actually practice D arrangement questions if you want to ensure that you've studied the whole content of probability. So the dearrangement formula is what has to be used here, and in fact only 4 students were getting dearranged and not 5 students here, because student S1 went to his own position R1, so the other 4 students got dearranged. So the number of ways in which they can get dearranged can be found out using the dearrangement formula, and in this case it will turn out to be 4 factorial multiplied by 1 minus 1 divided by 1 factorial plus 1 divided by 2 factorial, so on until 1 divided by 4 factorial. This turns out to be equal to 9. What are the total ways in which these people could have sat in the examination? There are 5 factorial ways in which these people could have sat in the examination. The probability is nothing but 9 divided by 5 factorial, a very straightforward and simple dearrangement question. The second question from the passage was not that straightforward, but this did not require you to use any formulae, but could have been solved with a little bit of logical thinking. Still a very simple question. So now S1 to S5 is sitting in R1 to R5, and now we've defined Ti as an event where Si and Si plus 1 don't sit together in the examination. And the probability that we've been asked to find out is the intersection of T1, T2, T3 and T4, which means that 1 and 2, 2 and 3, 3 and 4, 4 and 5 do not sit together. So people whose numbers are next to each other don't sit next to each other in the examination. So this question could be solved very logically, and what we're going to do is we're going to place S1, S2, S3, S4, S5 respectively in the first spot, and then look at what are the different ways in which the other students can be placed. It's not a very tedious process. If you do it neatly, it's going to be very easy to arrive at the answer. In fact, we had 14 different possibilities such that 1 and 2, 2 and 3, 3 and 4, 4 and 5 do not sit next to each other. And the total number of ways in which they can be arranged in the examination was 5 factorial ways. So the probability that T1, T2, T3 and T4 simultaneously happen is 14 divided by 5 factorial, which is 14 divided by 120, which turns out to be 7 divided by 60. So this probability question was actually a simple question, but you should have been aware of the concept of dearrangement. To make sure that you have covered the entire content of probability, please go through this section of dearrangement as well before you go into the examination hall. So I've solved a few questions for you from different sections of the question paper. Overall, every section from mathematics was tested either in paper 1 or paper 2. So in order to clear the advanced examination, there is no scope to leave any section of your NCERT textbook or the IIT JEE syllabus. Make sure that you go through everything, practice them rigorously, because the questions in the advanced examination are not very straightforward and simple, but as you have seen, if you are aware of the concepts, you can very quickly arrive at the solutions. Remember, the JEE advanced examination, it's not about scoring 100% marks, it's about being smart. Try to score 40, 50, 60% marks and try to score them in a very effective way without taking a lot of pressure. You should never be under pressure, because if you are under pressure, you will commit silly errors, and silly errors will make the difference between you entering into a prestigious college of national repute or not. IIT JEE examination, not an easy examination, but an examination which all of you can actually clear if you become a little smart and put in a little bit of extra effort in these 2 years. Happy learning, and I'm going to see you very soon with more such fun videos about the IIT JEE advanced examination.
For more videos and live lectures on the JEE, click on the subscribe button now.